Hello and welcome to another PlayBASIC tutorial. Today we're going to have a look at comparisons, primarily if-then comparisons and if-ENDIF blocks. So to find the tutorial about this stuff in the help, we would go to About, head down to Comparisons in this Learn Programming bit here. There's a lot of stuff in these ones here, but we'll pretty much have a look at the if-then stuff briefly, as well as a few other ones. I'm going to make assumptions throughout the video. I'm going to assume that you know what a variable is. I'm going to make other sort of basic assumptions about what the print statement is, those kinds of things. So if you don't really know, perhaps jump back and look at another one. Getting into our topic today, we want to look at why we would need comparisons first of all. Now, in a game, often we would have multiple characters on screen. We might have variables that represent the character's coordinates on screen or within the game world, and we need to do things like checking whether the character is running into some other character, so collisions are for comparisons. The basic structure of a comparison is going to be the if-then statement. So we have if something, then we do something else. So let's put together, this is not working code obviously. It probably would compile and run though if you tried it, and it does. It just happens to be that PB is assuming that something is a variable, and we're just falling out the end anyway. Let's put in some real variables. I don't know. Let's say we've got our score variable, and we want to add an extra life to our player. Let's say the score is currently 1,000. And the character has a variable, the player has another variable called lives. So they've got like 5 lives initially. You print this stuff out on the screen just to get a feel for what's going on, for what our variables contain, and then we'll have a comparison and we'll print the stuff out again to see what sort of changes we can make with these comparisons. So this is kind of the framework of our example, then we'll get it to do something useful. Let's get rid of this example statement, make something real. Okay, so in an if-then statement, you can check the syntax of these things if you want by putting the cursor over the red keyword and hitting F1. It takes us to information about if-then statements. It's a little jargony at the top here, I must admit, but we'll try and get rid of some of that jargon for you. So the basic syntax of these statements is if some expression. In this case, we're going to do a direct comparison. Let's say we wanted to print something on screen, or we wanted to bump the life counter or the lives count variable. In other words, add 1 to it when score equals 1,000. So we would go score equals 1,000. Then we'll say lives or old lives equals new lives plus 1. So if we run that, we'll get a feel for what it does. F5, by the way. So we're showing what score and lives was initially, and then what score and lives are after the comparison. And so obviously something happened. Our compare worked. Now what is this thing actually doing? So what if does is it's looking at this piece of code here, and in here we actually have an equality test. So PB is first doing the equality test, and what languages tend to do is they tend to break these these equality test things down into a yes or no. Is this check true or false? So false is generally represented as a 0, and true is generally represented as anything that's either 1 or actually any other number. So what happens in this piece of code is PB comes down, looks at this expression here, goes, oh yeah, or expression is just another way of saying formula, by the way. Looks at score, and it compares score with the literal value of 1,000. Now, if that is true, if score actually equals 1,000, and it does in this case because we've defined it as equaling 1,000 at the top of the program, then this expression here returns a 1. Then the if statement here then jumps on the status of this expression. So it's either going to, if this thing in here, whatever this expression happens to be, if that thing is true, if it's any value other than 0, we jump over here and we run the code that's after the then statement. In this case, we're adding an extra live to our lives variable. We're going old lives equals new lives plus 1. Ooh, that was a bit of a tongue twister, wasn't it? Alright, so we're getting an idea of how these things work. This is right again. Now, we can sort of test some of that jargon out by doing this. If I just put score in here, then I'll print, a little message to say that this is true. If we run this code again, we should have a message saying this is true. In other words, when it sees this piece of code here, it sees the if statement and goes, okay, we're going to make a comparison, we're going to make a decision whether to run the piece of code after the then statement or not. It looks at the expression you've given it and goes, okay, there's no other code but the variable, and it just compares that variable with 0. If the thing's 0, which is false in computer speak, or in programming speak in general, it doesn't do anything after the then. It just ignores that code completely, just skips past it, and it continues on with this line here. If the thing isn't 0, and we know it's not 0 in this particular example, then we're going to render this thing over here. We're going to do this thing over there. And I guess to understand why this is kind of useful, we need to sort of separate ourselves from the comparison structures, or the comparison itself, which is the comparison control, which is the if-then statements when used together, and the equality test, which is used in here. What you can do is you can do a whole bunch of things with these kind of equality tests. You can compare if score is equal to 1,000, or you can compare if score is not equal to something, or you can say is score greater than something or bigger than something else. Just to give you a few examples. Let's cut out this code here, and we'll do that. We'll show you what we can do. So we go if score equals 1,000, then print, yep, score is 1,000. Oop, this weird keyboard mapping on my remote keyboard drives me nuts. If score, now you can write non-equal a few different ways. The basic way is this symbol here. If it's not equal to, it's not equal to 1,000, then, oh, typos are coming in. Not 1,000. score is not 1000. Get rid of the lines counter for a second. We'll just cut down to the minimal code we need to see what's going on. If we display score, we know score is 1000 up here. Now we want to just check what code, which line of code gets becomes true and which one doesn't. Now hopefully you can look at that and go, well, looks to me like this bit of code here will be the true one, and this one here will be false. And it's false because score, the only way for this piece of code here to execute and print this message here out is if score is not equal to 1000. Let's try it out. Okay, so score is 1000, and it's printed our yes message or a yep message, but not the, it didn't print this message here. So what happens is when we do an inequality test or a non-equal to test, we're saying is this variable not equal to something, in this case the literal value of 1000, but it might be another variable too. You can use those kind of things. And if it is not equal, it actually returns a true, which is it returns a 1 state. If this returns a, which would mean that the if statement here would then, if the result of this calculation here, which is the inequality test, is a 1, then if goes, oh okay, cool. The expression that the person typed in is actually true, so they want me to run the code after the then. That's what would happen. Now we can use another type of if block. Generally these kind of inline if statements or if then statements are used to do a piece of code that makes one simple decision. So we have a comparison in here, and we're doing either a yes or no. Do we do this thing over here? Sometimes you might want to have a lot of code that's executed optionally. Let's make a bit more of a. So to do that, we use the if ENDIF block. So we have an if statement with an ENDIF statement, and we need something over here. This time we'll say if score equals 1000. We don't need a then. We don't need anything after that actually. So the then is not used with the ENDIF pairing. So the two pairings are if and then, and when you have those together, that's a single line comparison. And an if ENDIF make a multiple line comparison. I generally use if ENDIF, to be blunt, but it's probably a personal choice really. So we can have this same statement. We could go yes, I'm 1000 and this is the if ENDIF block of code. Let's run it. So we should get two messages because this statement here is true and this statement here is true, so it will run the code in between the two. Alright. We've got our if happening. Now, what we could do is we could get rid of these comparisons. Just focus on the if and if statements. So we can have another print statement in there or something like that. We could have junk. What? You know, junk. So we can put as many lines in between the two statements as we like. That's right. So what we get. Yeah, there you go. Why would we want to do that? Well, it's quite common to have a logic in programs that needs to go two ways. We need to handle a situation when something is true and handle a situation when something is false. Now, when this expression after the if resolves to be anything other than 0, so it's considered to be true, then the code after it will be executed. However many lines you want to put in here, that's how it works. If you want a behavior defined for when this expression is not true, so if you want to do something when this occurs and then do something else for when it's not true, you use the else. This is an if-else ENDIF block. Just look at the help up here again to see these kind of things in action. So I've kind of briefly looked at if, then introduce if ENDIF. We've got a few other variations there as well. So we've got some examples in there if you could really go through. An example there is pretty good actually. We're displaying a message. This message here, if lives is greater than 0. And if you read the code down, you can look at the variable here going, okay, lives is 3, gets to here, does a comparative test and compares lives. Is lives bigger than 0? And it will be, because lives was just set as 3 on the previous line. So the if statement goes, okay, the result of this compare here returned a 1, so I run this piece of code here. Once that code's run, it skips over the else. It doesn't run the else, or it doesn't run the statement after it. It just jumps to the end if. Let's see that in practice. So if I draw like a, I don't know, draw like a circle. So, I don't know, put it 1,000, 1,000 or something like that. 32 will make it true. Now, if we follow the logic through, we're assigning 1,000 to score, displaying score to the screen just so we can see it. We're hitting an if-else ENDIF block. The code does a comparison of score and a quality test to 1,000. If it does equal 1,000, and in this case we know that it will, it'll run the print statements in here. It hits the end of this section here and then jumps out from this. I'll put a space in here. We jump from here to the outside the ENDIF statement. So we're completely skipping over this circle. So we shouldn't see a circle at all. Just see a couple of print statements. Okay. What if I change the value of score? If we change score to, I don't know, 500. Now this time we're going to get a different behavior completely. This time we see a circle and we don't see the print messages at all. So we're actually selectively executing two pieces of code. We can have lots of different code in here. I mean, don't be sort of fooled by, you might want to, I don't know. Let's draw another circle. At 500, something like that. 300. Run it again. Wow, there we go. A couple of circles. So the behavior is two completely separate behaviors given the condition of this comparison. So what we end up here was we'll go back through the thing again. So at the top we're assigning score, the score variable to 500. We're displaying that variable. We're doing a comparison. We're comparing score with 1,000. Is score equal to 1,000? If it's not, that comparison returns a 0. The if looks at the result of the comparison and goes, okay, you returned 0, so you're not equal. And when it's not equal and you have an if statement, an else statement, it goes, okay, skips over this block of code completely and lands in here. lands after this else, then executes whatever you've got between here and there. So we can use if else if to choose a pathway for our program to do something. Okay. Let's make a little practical example out of this. Let's get rid of this stuff altogether. We're going to introduce a few more commands. We'll make a do loop, so our program's going to be just sitting there doing something. I don't know. Let's set the frames per second to 20, so we'll throttle the speed of the application back a bit. In our main do loop, we'll clear the screen to an RGB colour of, I don't know, 20, 30, 40. If we run that to get an idea of what the screen's going to look like, it's kind of a darky, kind of grey colour. Now, let's do something new. We'll read the mouse position. Now, the mouse is one of those ones that actually has the mouse position on screen. It has an X and Y coordinate. So we have a position across the horizontal axis I should say, and the vertical axis. Can't get the words out. So we use the mouse X and the mouse Y to do those things. Alright, so this piece of code here is reading the mouse's current coordinate. What we'll do is we'll draw a circle. We'll have a circle. We'll use the mouse's current X and Y position. We'll draw like a big fat circle of 40, something like that. And we'll tell it to fill it. Right again. Alright, so we've got a circle that's kind of at our mouse position. Now I've limited the frames per second of the application because the capturing software just can't keep up otherwise. That was a bit jerky. Now let's make a comparison. What if we said if the mouse X position is greater than 400, let's do something. We'll draw, oops, keyboard mapping again, mouse X bigger than 400, and again. Now what we can do with comparisons, let's run it first of all. So when I'm over this side of the screen, not much is happening. When I get past this point, our message appears. Obviously that's where the pixel 400 is on our screen. Move back, gone. Move across, gone. So we've got a situation now where we're actually using our straight behaviours to do something practical. What we could do is we could nest a comparison inside this comparison. Pretty freaky. Let's say, I don't know, we'll check if X is bigger than 500. Cut and paste our message because I'm lazy. Okay, so when we should get 2 messages when we move beyond 500. So we're just hit our 400 threshold but no 500 message, and now there should be a second one. We're getting both messages because when the mouse is at its current location, which I don't know what the pixel location is, but it's beyond both of those things. We'll do that. We'll draw the MX. We'll print them to the screen so I can see what's going on. Okay, so our mouse position is currently at 421 on the x-axis and 212 on the y. keep moving across, and boom, we move back and they disappear. So we're using a comparison to do that. Yeah, I apologise for this being pretty mundane, kind of boring stuff, but we really just have to get through this kind of stuff. We're going to be using comparisons a lot in our applications, and what about if we do something a bit more? Well, let's make another kind of comparison here. Make the logic a bit more advanced. Not much. Nope. Nope. Mouse X is smaller than 500. Now this might do something that you may not expect. We've got our two comparisons again. We have our first comparison out here. So when mouse is bigger than 400, we're displaying this, and then we're doing a comparison of the logic in here. So we'll either get this message if mouse is bigger than 500, or we'll get that message if it's not. Notice there's no printing over here. Nothing will be printed until the mouse is beyond that point. This is kind of a fundamental idea we're looking at here. And this is the order of these operations. We're telling it to do this comparison, but we don't have any behavior to handle if mouse is less than here. So if you wanted this message here to display if mouse is smaller than 500, you would need to rearrange the logic. We could do that like this. We could use a second comparison. We could split the logic up really. We could go mouse X, if it's smaller than 500, we'll print that message. We don't need the if else message here at all. So we'll actually get this message here printed all the time, provided the x coordinate is less than 500. There is one time when that will not work. You'll actually not get anything printed. See if we can try and make it happen. There we go. When the mouse is perfectly at 500, our comparisons are checking to see if the mouse's x coordinate is bigger than 500 or less than 500. It never compares if the mouse's coordinate is equal to 500. That's actually one of the hidden tricks of these comparison things. Sometimes we can make sort of mistakes in our code where we think our code is doing one thing and our logic is kind of faulty. The order of our comparisons is wrong. Let's do something a bit more complicated. We'll leave the print statements there. All this is kind of pretty bogus. Let's make a comparison. Let's check if the mouse is within a particular zone of the screen, and we'll do all of the compares we need to do. We're going to use, first we'll check the x-axis. Let's say we want to make a comparison and check if the, I don't know, let's pick an area. So we'll go, if the mouse x is bigger than 500, we'll end that if statement. So the code inside here will only ever get executed when the mouse x coordinate is bigger than 500. We'll say mouse x, next comparison we'll say less than 600. We'll close that end statement. So let's put another statement in here. We'll say, just to give us some feedback, mouse is within 500 and 600. Let's run it. And there we go. So it's checking whether it's within this zone and giving us a bit of a feedback on that. But you notice vertically, it doesn't matter where we are vertically on the screen, it'll always do that. If you wanted to have like a square that the mouse reacted to and nothing else, then we need to actually do some comparisons on the vertical axis. So we do the same thing. We have a compare inside here. We go mouse Y. We'll try it for 300, let's say. Bigger than 300, oop, not 3000. ENDIF, and we'll do another comparison. Mouse Y lower than 400. We'll close that statement there. Now we'll move this comparison here. Sorry, this print statement. We'll say we'll print a message. Mouse is within zone. Yeah, that'll do. Right, no message. Where was the zone? There it is. Probably should display the zone, actually, shouldn't we? Let's do that again. Now, we'll draw a box, an open box, to represent that zone. Box, its x coordinate is at 500, and its top y coordinate is 300, so I'll draw that there. Its right x coordinate is at 600, and the bottom part of it's at 400. We'll tell it that false to not, so it doesn't fill it. Well, that's where our zone is. So all we're in the zone here, nothing. The circle will go inside because it's not comparing the circle, we're comparing the coordinate where the mouse is. And there it is, we've moved inside and out. That's a pretty common comparison you'll be doing in games. You'll be checking if two things overlap, or you'll be checking if something's within a set of criteria that you've defined. It's kind of hard to define what those criteria are just in a tutorial like this, but okay, so if we want to clean up our code a little bit more, we can take it the next step and we can do something. We can introduce the AND statement. This means we can get rid of some of these comparisons. Now, some people like to put their comparisons in brackets. In PB you don't actually have to, but sometimes it can actually help clear things up. I'll remove the accompanying ENDIF down here. So, what are we doing? Well, this is a little bit more complicated, probably beyond the scope of this chat, but PB, when it sees this if statement here, looks forward at the expression, looks all the way through it here. Now we see the first brackets, and we resolve the code inside that. And it's going to resolve to, it's either going to be a true or false result. It then goes over and looks at this comparison here. That resolves to a true or false result, so it's either 1 or 0. Now at the end of both comparisons, it uses the bit-based logic to AND them together. Now that one's going to be a bit more challenging. It's probably requires its own tutorial altogether. We've got a thing in here called operators, bitwise. That's for shortcuts. Okay. AND has its own set of rules. When we take two values that are 1 or 0, and on either side of it, so we've got this calculation here and this calculation here, that are both resolved down to either a 1 or 0 result. The AND rule says that if both of the values on either side of it are 1, this entire thing returns are true, a value of 1. If only one side is 1 and the other is true, and this one here is false, then the whole thing comes out as false. And vice versa. If this is false and that is true, the whole thing is true. And if neither of these sides here is true, then you get false as well. So the only way this if statement here is going to fall through and do the next comparisons is if our x value is bigger than 500 and it's lower than 600. So it's within that range. We'll run that, see how we go. So mouse is up here, we are within that range, and now we're within the range of both, with successfully within the x range and the y range as well. Let's do that again for the y-axis. You don't have to put the brackets around it, but some people sort of like that. PB's a bit liberal in some of those aspects. Yeah, it depends on where you come from as to yeah, whether you like that or not. Okay, let's run this again. And it goes off when we go within the zone and not outside the zone. Now, you don't have to stop at just 2 of these comparisons. This is the crazy thing. You can actually stick all of this stuff into one long expression and use an AND statement as well. In other words, the only time this if statement here is ever going to run the code inside here is if all of these different comparisons individually return true. If they all return true, then we are within the zone. If one of them returns false, we're outside of the zone. Let's try it. So we're all working good there. Inside, and we're working. I hope we've given you something useful to go with through there. I know we sort of haven't done much sort of practical sort of stuff. You know, my advice would be to jump through and look at those tutorials that are in the help files. Look at how comparisons are used in people's programs. You know, often you tend to need a very specific usage to see where you need to use comparisons, and unfortunately trying to dream up some idea tends not to work very well. As always, if you have troubles, get on the forums, you know, ask your question out in the open. Other people are probably having the same troubles as you are. Anyway, thanks for watching, and I hope you enjoy learning to program. I know it's can be very challenging to get off the ground, and I really feel for people who are struggling. But until next time, thanks for watching, and we'll see you again. Bye.